In this video, we'll finish up our discussion of 7.3 with operational properties of the Laplace transformation. We have one more theorem, and then I'll close out with an example, and then we'll solve one more diffie Q using this to finish up the section. All right, so second translation theorem. What if we can't get the function that is times our Heaviside function, our unit step function, to a t minus a? Is there a way around it? Well, this theorem says yes, there is. I just have to change the input of my g on the other side to the t plus a. So let's show how this works out. So for a little proof, we're going to let f of t minus a equal g of t. Okay, if that's the case, then g of t plus a is equal to f of t. Think about that for a moment if you need to. Just let them be two different functions, and you can see that it does work out. Okay, so if that's the case, then the Laplace of ft minus a times the Heaviside function of t minus a, that follows the theorems from the last couple of videos. I get e to the negative as times the Laplace of f of t. Right? And then we e to the negative as times the Laplace, and f of t is just g of t plus a. Well, we replaced it to begin with, right? So we have proven it. All right. So let's use it. We have this L sine of t, u of t minus pi over 2. It's going to take a little bit of trig substitution too. Not like in Calc 2, but just an identity. All right, so I have this. Let's follow what they gave us. They said e to the negative pi over 2 s, and then it's going to be times the Laplace of sine of t plus pi over 2. The theorem tells us. Now, you might not see this right away, but sine of t plus pi over 2 is just cosine of t. All right, so if that's the case, then this is e to the negative pi over 2s times the Laplace of cosine of t. Okay, and I think this is really done with maybe a minus in there, but because cosine of negative t is the same thing as cosine of t, I think it works out here. Okay, so then now we can take our Laplace of cosine, which is going to give us an s, and then s squared plus 1, e to the negative pi over 2s. There's our solution. Okay, so this one was an ideal setup for that, right? Since we do know that sine of pi over 2 is equal to cosine of t, but it can help out. All right, so let's take a look at one more diffie Q solved in this manner, where we have to apply some of these theorems here in this next video. Okay, so we have this diffie Q y prime plus 2y equals f of t, y of 0 equals 0, and then we have the function from t from 0 to 1 of 0, 1 on. So the Laplace of y prime plus 2y is equal to the Laplace of, oh, we should redefine our function first. So let's go ahead and do that. F of t. We'll make a Heaviside function. Okay, I'm going to get a t and then a minus t once we hit 1. So it's t up to 1, and then it goes away to 0 at that point. So on this side, then I'm going to have t minus t, Heaviside t minus 1. All right. So the left side, we get a capital Y of s times the times s minus f y of 0. I always want to go back to f's there. plus 2 times capital Y of S. And that equals, okay, L of t is going to be 1 over S squared. Okay, and then we can use this theorem that we just came up with. So this is going to be minus e to the negative s times the Laplace of t plus 1. We added 1 to the other side, right? Minus 1 was here. I added 1 to the Laplace. That's exactly the last theorem that we had. Okay, this is, well, I think we're good there. Right? The y of 0 is 0, so this is gone. Let's rewrite. Now I have, I'm going to go ahead and factor out the capital Y of S here. And I'm going to have an S plus 2 equals 1 over S squared minus, and then we're going to get minus e to the negative S, and then t plus 1, I'm going to get 1 over S squared plus 1 over S. All right? Nothing changes for a moment on the left side. I'm going to leave 1 over S squared by itself. E to the negative S, I'm going to leave it there as well. And then let's do a common denominator here. I'm going to get an S plus 1 over S squared. I put the S up front. I like it better than the other way flipped. But okay, so I have that. Now I'm going to divide everything by S plus 2. All right, so I get 1 over S squared times S plus 2 minus e to the negative S times, and I'm going to get S squared times S plus 2, eh, S plus 1 on top. There we go. Okay, we're going to, let's do, you can see, no, we'll do them separately. So we are going to do a fraction decomposition for the first one. It's going to be A over S plus B over S squared plus C over S plus 2, right? If S equals 0, oh, we should multiply that out first. I always forget. 1 equals AS times S plus 2 plus B times S plus 2 plus C times S squared. All right, if S equals 0, then we are going to get C equals 1/2. If S equals negative 2, we plug that in, we'll get A equals 1/4. And then we'll do an S equals negative 1. And when we plug all that in, we get 1 equals A minus B plus C. Plugging all those in, we're going to get B equals negative 1/4. Just plugging it in during arithmetic. So those work out there. So I'm going to put a little boxed off there. Okay, then we're going to do it for the next one, which is just going to be the S plus 1 over the same thing. I guess we could split them, right? But I'm going to put them all in one so I can just have them. So I'm going to have an A over S, B over S squared, plus C over S plus 2. I get S plus 1. S plus 1 equals AS times S plus 2 plus B times S plus 2 plus C times S squared. Okay, and we'll run through, I think these same numbers would make sense. Yep. So S equals 0, right? That means I'm going to get, if we run S through everything, I'm going to get a B equals 1/2. S equals negative 2. I'm going to get a negative 1 on the left side, but if I plug everything on the right, I'll get a 4C, which means C is negative 1/4. I plug in S equals negative 1. I'll get 0 equals A plus B plus C. If I plug those in, I'm going to get an A equals 1/4. All right, so I'm going to rewrite capital Y of S. I do know one thing: by the end of this course, we have one more lesson. You should be really good at fraction decomposition. All right, so we're going to get negative 1/4 over S plus 1/2 over S squared plus 1/4 Hold up, I think in my notes I might have made a mistake. Okay, so yeah, I made some mistakes in my notes. That's okay. So we'll fix them here. Okay, A is 1/4, and then B is going to be negative 1/4, and then C is 1/2. There we go. We'll go there. Glad we caught it here. One, can't write, come on. 1/2 over S plus 2. Okay, and then we're going to minus E to the negative S times, and then this one's going to be 1/4 over S plus 1/2 over S squared plus negative 1/4 over S plus 2. Okay, so we are going to get, now that if we take the inverse Laplace of all of that, it's not an F, it's a Y of t. Okay, that's going to be equal to 1/4 minus 1/4 t, and then plus 1/2 e to the negative 2t minus, and then now we're going to get all these values and we're going to use our theorem. So negative 1/4, and it's going to be Laplace of 1 over s. But we got to remember to change t to the t minus 1. Okay, and then we also have 1/2 Laplace of 1 over s squared. We'll change t to the Heaviside function of t minus 1. And then the last thing is going to be a minus 1/4 Laplace of 1 over s plus 2. And then also change our t's. All right, so we can jump to our final answer here. Y of t is equal to 1/4 minus 1/4 t plus 1/2 e to the negative 2t minus 1/4 Laplace. Oh, we can go ahead and take our Laplace now, silly. All right, so we're going to get 1/4, and that's just going to be a 1, so it's going to be times 2 unit step function and heaviside. I keep trying to combine the two when I say them. Then I'm going to get a 1/2. That's just a t, but I got to change t to t minus 1 times the heaviside function. And then I'm going to get minus 1/4, and it's an e to the negative 2, and it's usually a t, but I've got to do a t minus 1 times the heaviside function. I could have done each one individually and then multiplied them in a giant parentheses times the heaviside function. That would also would work. I guess that would look prettier, so I guess I'll do it here. Y of t is equal to 1/4 minus 1/4 t plus 1/2 e to the negative 2t. Then we can do this. We'll do, I guess, a minus 1/4 minus a 1/2 t minus 1 plus a 1/4 e to the negative 2t plus 2, all that times the heavy side minus t minus 1. All right, we'll just leave it there. So there is our final solution of our diff EQ.